Hello. Um, so in this video, I'm going to try and use a very dodgy metaphor to try to articulate some of the challenges around software development and how on the difference from the difference in being able to just write code and write code as part of a well architected application. And I'm going to try and relate software development to house building, which may or may not work, but we'll see. And this is in response to a project I've been working on where the design of the application shows that there was some original intention around the architecture of the application to do things in a particular way, to separate things out in a certain way, to create certain things. That the pattern for that, the architectural pattern is there, but the implementation of the pattern has meant that we've kind of lost all the kind of benefits of that pattern. So, getting into the specifics, we have a situation where we've got a web services set up, a web application sitting in front of those web services, and that web application rendering HTML, CSS, and JavaScript for a front end. And rather than the business logic relevant to the web services being in the web service layer, it's bleeding through into the front end web application, and actually a lot of it's bleeding through into the JavaScript side of things, meaning that in order to the only way of getting that the full functionality of the system, the full functionality that required within the system is from an execution of that JavaScript. Nothing. If something else wanted to access those web services, they would be not much use on their own, other than as a proxy to a database, without then providing, re-implementing the business logic currently done in JavaScript. So I'm gonna try and use a house building metaphor here, and I'm going to look at simplify this somewhat and also show my ignorance of house building. I'm going to simplify this somewhat down to two roles: that of the architect and that of the bricklayer. So in this metaphor, the architect of the house is going to be the technical architect in software development. The bricklayer would be the developer. And the architect will design a house, and how that house is built, what that house needs to, not just what it looks like, but also what the key things are within that property in order to give it structural integrity, and generally, so the house kind of works in the way it's supposed to, meets all other kind of things, environmental factors and all those kinds of things. So things from the foundations of the property, the how different aspects of the property need to kind of join together, how different things connect, how perhaps where the joists are within the building, how the roof kind of connects on, all these things that go into making up that the detail of not just saying we've got something that looks like a little house with windows and a door, but actually how do we construct this thing? And the outputs from that architect may well be the technical plans and also some, more kind of visual sort of design, some more graphic design type things to say this is what the end result will look like. When the bricklayer comes to start work on that house, they could look at the picture of what the end results needs to look like and start laying bricks. If the bricklayer knows what bricks are and what cement is, and they can, connect bricks together using cement, chances are they could look at the picture of what the house needed to look like and start putting bricks on the ground and stacking them up, connecting them with cement, and eventually they would get to something that looked vaguely like the house in the architect's design. And when you sort of stand back and look at it, it may exhibit some of the kind of characteristics of that design. But if that was the approach that was taken, then under closer inspection and possibly with quite quickly, it would become apparent that what had been built did not conform to the to the original plans. And the intention of the architect, of what the architects kind of wanted to be created, and we might see, for example, things like foundations of the property are missing. So the integrity of the house is now kind of it's going to lean to one side and might just completely fall down because there's no solid foundations to sit on. We might find that the bricklayer has not understood the difference between, say, a single brick wall and a cavity wall, where there are two brick walls side by side connected together. May not have understood the differences there and what was required. They may not have implemented what the architects wanted. The architects may have wanted a cavity wall with these two walls together. Bricklayer may have just built a single wall. So we're going to lose some of the insulating properties of the wall of the house. The bricklayer may not have understood how to connect bricks together at the corner of the property, so we may not have the integrity of the those connections at the corner that we wanted. When it comes to doors and windows, the bricklayer may not have understood the need for structural integrity across the top of the door. The insertion of lintels and things like that to provide that integrity. So if they're just laying bricks across the top, then it's gonna sag down and eventually may well fall down, unless it's being propped up unless there's enough support within the door itself. They may not have understood how the joists need to go across, and connect, sit on top of the walls at different floors in the property. So we may have kind of lost the kind of integrity there. And all of these kind of issues are going to become apparent over time, that we're missing these things. And I'm guessing in the case of house building, those things may become apparent very, very quickly. And I think it's a similar thing with the software development. If you know how to write code, if you can write, if you understand how to declare a variable, you understand how to write an if statement, a switch statement, a for loop, a while loop, you can write a function, you can write a class, then you have the building blocks that are essentially the same as putting bricks together with cement. That's what they are. But on their own, that's knowledge on its own will only get you so far, and you can either learn the hard way that when you start combining things together without a regard to some of the bigger concepts and the need for that kind of connection between the architecture and the code, it's going to be a painful journey. It's going to be a very painful journey. So just coming back to the kind of the bricklayer metaphor. If the bricklayer has not understood those things, there are, I guess, at least a couple of reasons why that might be the case. One of them is that the bricklayer doesn't understand the concepts being described by the architect: foundations, lintels, joists, cavity walls, all these things. Maybe he doesn't understand those things. Or it could be that the bricklayer understands those things but doesn't know how to translate that understanding of what the thing is into an implementation. And I think that the two things there are subtly different. One can understand what a cavity wall is and not necessarily know how to construct it. I'm fairly certain that I could kind of put single bricks one on top of the other, and I understand what a cavity wall is. I'm not sure I could build a cavity wall in the correct way, with all the ties and all those kind of things in there and stuff. There's other aspects of that. So looking at the software development side of it, if you don't have the knowledge about those kind of bigger concepts, or you don't see the importance of them, you don't understand them, or you can't implement them, then you are going to build the house in the same way as the bricklayer who hasn't kind of adhered to the architectural plans, and sooner or later, I don't want to take the metaphor too literally, but it's going to come crumbling down around you. So being able to understanding the concepts of kind of writing code is fine for a start off. But if you're going to work to an architectural plan, you need to understand that architectural plan. If you don't understand the architectural plan, don't work to it. Don't use those kind of concepts. There's no point implementing web services if you don't understand the importance of those web services and how to design your code and know where to put the functionality that describing your code, where within the system to put that functionality. If that's not clear, then chances are you're going to kind of start implementing things that look like the architectural pattern, but aren't actually, adhering to the intention there. And in the same way that the bricklayer needs to understand, there are two aspects of it. One is understanding what the architectural pattern, what the whole architectural kind of concept, the big picture is, and what these kind of big concepts are, and why they're important. And the other aspect of it is understanding individual and knowing particular techniques that the bricklayer can use to build up, to allow them to implement things that then meet the needs of that architectural plan. So the big picture, the conceptual stuff is understanding about the structural integrity. It's about understanding the environmental kind of impact, the kind of the heat loss and all those kinds of things, and why they're important. And the techniques are things like how we build a cavity wall, how to lay foundations, how to put joists into a property, all those kinds of things. So you've got that combination of techniques and the understanding of the concepts that are both important to be able to kind of go into that. In the same way, I think with software development, you need to understand the bigger concepts. So if you've got web services and front end application, and you've got JavaScript and all these different elements and a database, you need to understand why all those elements exist and how they fit together. Because if you don't understand how they fit together and why they're there, you may as well just not have them there. You may as well start off and just write a really very, very basic application. Chances are you're going to implement that better than if you try and implement something much more complex without understanding why it's there. And secondly, there are techniques that are needed by the developer in order to start to implement that technical architecture plan. And those techniques for me are things like the single responsibility principle, dependency injection, being able to write testable code. These are techniques that will allow you to start putting your understanding of things into some practice. The conceptual understanding is important. If you don't know how to implement things like the single responsibility principle, again, your implementation is not going to work out as well as you want. If you understand the individual techniques, like single responsibility principle, but don't understand the big concepts, you can still write a very neat kind of code, but put it in the wrong place. So need to know both things are important. The conceptual understanding and the techniques to use are both vitally important there. I'm now into something quite dangerous and trying to extend that metaphor a little bit to just touch on some other things. So when I've been asked about things like stored procedures, databases, and design patterns, and I would just, so extending the metaphor here, I might say that the bricklayer has options available to them, such as whether they use a bucket and a trowel to mix their cement or whether they use a cement mixer. They have options available to them in terms of whether they use red bricks, small red bricks, or bigger blue breeze blocks. Terrible analogy, but it might seem on the face of it that using the cement mixer rather than a bucket and a trowel is a better way to mix cement. And if you know what you're doing and can work fast enough, then yeah, chances are it is a better way of working. But if you can't work fast enough to utilize what's coming out of the cement mixer, then you may find that your cement is going off and hardening quicker than you can use it. In which case, the benefits that would have been there from the cement mixer, you no longer get. And in fact, actually, you might have been better off just mixing in a bucket with a trowel and mixing the amount that you can actually use. That's probably a terrible analogy, but I hope the kind of even if the reality of that isn't true, I hope the kind of meaning is clear. Likewise, if you've got the option between building something using small red bricks and bigger blue breeze blocks, to the uninitiated, you might think, well, a big blue breeze block, if I use those, it's going to be quicker to build the property because the bricks are bigger. So you might think that let's use that. But actually, again, if one understands that a bit more, one realises that the red breeze block, also the red bricks, are, yes, they're smaller, yes, it requires more kind of work, but they're much harder than the blue breeze blocks and are suitable for building a supporting wall, whereas a blue breeze block is not suitable for a supporting wall. A blue breeze block is only suitable for a dividing wall. So understanding kind of when and the time and the place to use those different things is important before you start using them. So likewise, I would say things like stored procedures are very good. They can be used very effectively. But if you don't know how to use it correctly, and you haven't got the other aspects of your property, of your building sorted right first, so I'm now mixing the two things. Using stored procedures are good, but if your application has not been, if the code in your application is not implemented well, and you don't know how to use the stored procedures effectively, then you're not going to get any benefit from it. And in fact, you may well just make the situation worse, in the same way that if you start using blue breeze blocks, in the property, thinking it's going to make things quicker, and not realizing kind of what you're doing, or you're building dividing walls using red bricks or whatever. You're using things because you think it's going to gain you an advantage, and used in the right way and in the right place, it may well give you an advantage, but used in the wrong place, it just causes a problem. So, and a slight break from that analogy, stored procedures, I would say, very good, but not worth worrying about until you've got the basics of the application correct. For me, the stored procedures is icing on the cake. It's not the foundations of the application. Likewise, if you with design patterns, very, very good, but if you're writing code file, if you're not following things like the single responsibility principle, and you're writing 4,000 line long class files, then you're never going to be able to apply a design pattern to that. When you've got your single responsibility principle and you have things split out into their separate elements, then you can start looking at those elements and maybe saying, actually, do you know what? Maybe there is a pattern there that kind of follows it, whether it's a factory or a decorator or whatever it is. You can start to kind of look at those, but you can't. The design patterns build on some of the other principles, and you could argue that if you follow the design patterns, maybe that would encourage you to sort the code out according to things like the single responsibility principle anyway. But it just feels to me like it'd be better to get the basic understanding around why first, and be able to kind of implement that things like the single responsibility principle, dependency injection, understand why you're doing it, build the design patterns on top of that. And if you can get those basics right, then you stand a much better chance of producing a software application that not only fulfills the functional criteria that have been set, but is also sustainable, maintainable, and actually provides some pleasure to work on, rather than being terrified every time you go in there and try and make a change that something else is going to break, and worrying that if I change this, what else is going to happen within the system. It's not a it won't solve all problems, but it'll solve a lot of them. So there you go. House building and software development, pretty much the same thing.